Software Engineering Radio, episode 39, interview with Steve Vinoski. Hi everybody, this is a new episode of Software Engineering Radio, another interview episode. Today, we are pleased to welcome Steve Vinoski on the podcast. Steve is the Chief Engineer of Product Innovation for IONA Technologies. The IONA Technologies, you might know, it's a quite well-known middleware vendor. And Steve is actually what you'd call a middleware guru. He has been involved with CORBA quite a bit. He's now working with SOA and enterprise integration and messaging. So in this episode, we are mainly going to talk about various aspects of middleware and CORBA. So we want to thank Steve for agreeing to be on the podcast and have fun listening. By the way, I just wanted to mention we have recorded this episode also at the JAU conference in October 2006 in Aarhus, Denmark. So again, you might hear some background noise from the exhibition area. The quality is still really good, I think. So have fun listening. Okay, Steve, welcome to this interview on Software Engineering Radio.
Thank you.
As our listeners might have guessed already, we're probably going to talk mostly about middleware, since you're definitely a middleware person. So how did you get first involved in building middleware communication infrastructure? What's your background there?
Okay, I was at Apollo Computer in the late 1980s, and I was actually working on hardware, so I have an electrical engineering background. Mm-hmm. I started out helping make chips at TI, and I fell in love with software. So over time, I moved more and more into software. So at Apollo, I was working on a system that was a diagnostic system that would let a remote user debug the hardware. Mm-hmm. It was called RISE. It was Remote Interactive Scan Environment. Scan technology is a certain hardware technology for testing. Mm-hmm. And so RISE, or RISE++ actually, was written in C++, but it had a tickle front end where you had commands that you could issue the thing. Yep. So you could sit at a workstation, Apollo workstation that would be, fully up and running and everything. The machine you're working on is completely shut down. It just had a small, 20K RPC server inside in it was a diagnostic CPU. Yep. And that was my first distributed system. I had to write the protocol to do that. Mm-hmm. And shortly after that, HP bought Apollo, and they kind of, shifted things around, got rid of the group I was in, so I had to find something else to do. And that's when CORBA was starting up. And that group was, Jim Waldo was the technical leader that was at HP.
CORBA?
Yeah, of the CORBA development at HP.
Okay.
And it was the only group I knew of in the company, or where I was in Massachusetts, that was actually writing C++ code. So I joined there, and the rest is history.
Yeah. So how many ORBs did you actually implement?
So let's see. I think the count is 6.
Okay.
When I was at HP, the group there built the first kind of prototype ORB for the OMG before the CORBA spec was finished, just to kind of show, kind of show what it was or what it would be like. Yeah. And I joined the group right as they finished that one, so I don't count that one. Okay. But then we worked on a couple more in that group, and then over time, the group changed and got different managers and different, pushed into different organizations and stuff, and they never really sold any of the ORBs until probably the mid-90s. Mm-hmm. And by then, we had written 3 or 4, 5, and then I went to IONA and worked on the one there, Orbix 2000, or Orbix 6, as it's called now. Yeah. So I think it's 6.
So how did they differ over time? Obviously, you learned from doing the previous ones, but what's kind of the major differences?
Well, I think the early ones were built on previous technology. So Apollo had a network computing system that evolved. NCS went into DCE.
NCS is?
Network computing system.
And DCE is a distributed communications environment.
Right. So DCE was bigger than just NCS, but NCS played a major role. Other parts from DEC came into DCE as well. Yep. So the early ORBs were all built on top of DCE, basically.
So
NCS
API, basically.
Yeah, it's sort of like taking that fundamental infrastructure and then putting a different API on top of it.
Yeah.
And DCE and NCS both had this sort of little-known feature that they could actually do distributed objects.
Mm-hmm.
They weren't usually used that way. They were used as pure RPC systems.
Yeah.
But they had, in the protocol, a field for an object identifier, basically, so you could target specific objects. So the early ones made use of that. As we went on, the CORBA spec matured, and I remember sitting around, kind of sitting there thinking, what are these type code things? What are they? What are they meant to be? Because the spec wasn't very clear. It came from, that part of the spec came from other vendors, not from HP and Sun. HP and Sun were doing joint development back then. Mm-hmm. And it was all the static side of CORBA, came from us, and then this dynamic invocation stuff came from Hyperdesk and Digital Equipment Corporation. So we were kind of puzzling, we know how to build the static side, but how do you build this type code and DII and stuff? Struggled with that for a long time. It's funny looking back on it now, it's so simple, Eventually figured it. Once we figured out what they were. Yeah. But over time, the infrastructure shifted away from using DCE to IOP and building your own kind of your own listeners and your own handlers of requests and dispatchers and everything else. It was just a learning process over time of figuring out what the spec was trying to do, tightening up the spec. So while we're implementing these things, we're also in the OMG kind of, can we fix this? Can we fix that? Yeah. So
you mentioned before that DCE basically was like distributed APIs, stateless, and CORBA provided these object notions. Now, current hype more or less goes back to services. Yeah. So, and also probably CORBA best practices will tell you that you should use rather coarse-grained, kind of more component-like, maybe stateless objects instead of having these fine-grained objects. So how successful was the object part of CORBA actually? Was it the right direction?
Well, was
it the right notion to communicate?
Right. That's a hard question. I think it really depends on what you're trying to do with it. There were certain systems that were very successful with that particular approach, and having stateful objects versus stateless objects and the granularity and stuff, as people struggled with all that for years. If you look at systems like the services like the naming service or the standard kind of CORBA services, those are object oriented, distributed object, and people work with them and they work really well. Certainly have plenty of customers that lots of telcos and manufacturing and finance companies that have used CORBA, and they kind of get it after a while, and they find a way that works for them.
Reason I was asking was that these, if you have objects and you distribute the responsibilities, as CRC cards basically tell you, then you get a lot of fine-grained interactions, and these obviously don't scale over the network. So there's a difference, kind of.
Yeah, I think there's a bit of a backlash right now for distributed objects, and services are sort of ignoring all that stuff again. They're just saying, here's the service over here, and go call it, and people want stateless services naturally because they're easier to scale. Yep. And so I think the distributed object paradigm has gotten kind of a bad name, but that's natural when technology shifts. You kind of have to play down the previous one. Yep. So I don't think that it's necessarily wrong or bad. It's for certain applications it's exactly right, and pretty much. For example, anytime you make a phone call in most parts of the world, you're going through some CORBA software in some fashion, and the stuff's going to be around for another 15 or 20 years anyway in those systems.
Which brings us to the question of the future of CORBA. But first, I'd like to go back briefly about the implementation in ORBs. We all know this POSA 2 book, right? Those patterns for distributed systems,
right?
How many of these patterns have you actually used, or which are the most important or critical ones? Can you characterize that?
Well, I don't know if I can recall the pattern names off the top of my head, anyway. But I believe I was a reviewer for that book
probably
before it was published, and I just remembered as I went through the book kind of going, wow, this is exactly right. Yes, we use this, we use this, we use this.
Yeah.
And it very well, succinctly captured a lot of the work that we had done basically through the 90s on building these systems. And so I think, a lot of Doug Schmidt's work, for example, and the papers he put together, and just, people attacking this issue, trying to figure out what the patterns were and characterize them and write them down. And again, it's like that type code thing that I mentioned. When you read the patterns now, you just go, well, of course you do it that way. But to get there took quite a while. So that book in particular is it's a very accurate kind of collection of the patterns that you do use. Yeah. I think sometimes you run into people look at patterns books and say, well, do we really use these things? And in that case, yes, pretty much all of them. Yeah.
So, okay, now, what is the future of CORBA? My personal impression is that it's more or less happening in technical and embedded systems these days and not much in business areas, business systems.
I think what's happening is, in terms of you can look at it different ways. In the OMG, a lot of the CORBA development is in the real-time embedded space. Yeah. So those are the guys, and that makes sense, because the market for CORBA in the enterprise is mature, but the market for CORBA in real time, those guys are more conservative. So they're kind of now getting to trust it. And so for them, it's kind of a newer thing. So in the OMG, a lot of what's happening in CORBA does get directed by that domain. In the market, we still see some people picking it up. And again, it's the more conservative customer. In Asia Pacific, for example, it's very popular. For them, CORBA is relatively new in a way. So I keep getting asked to go to Beijing. We have an office in Beijing, and they keep saying, Steve, you need to come over to Beijing because there's all these CORBA fans who want to meet you. And it's just a long trip. I don't know if I'd want to do it. But so different parts of the world have also kind of a different view on where the CORBA market is. So can you maybe briefly explain what the differences between the normal CORBA and real-time CORBA and maybe minimum CORBA are? Well, I'm not sure of all the details.
Broad thing.
But I mean, normal CORBA has all the features that it's accrued over the years. Minimal CORBA is sort of like, what do we really need to get a system up and running, or what are the features we use most? And you can drop a lot of features that kind of make the whole thing more complex.
Like, for example, the dynamic stuff, which is also important in the embedded world.
Right. In the embedded world, in fact, most CORBA applications use the static approach, and the dynamic approach is good if you need it, but if you don't need it, it's kind of like you can just throw it aside. A lot of the code that you have to write to implement the dynamic stuff, once you figure it out again, like type codes, it's not that hard. It's just very tedious, and it's very large.
A lot of stuff.
And if you can take that out, you're obviously going to save your application space and quicker load times, all that stuff. So, and then the real-time CORBA, real-time embedded systems, they have to deal with priorities and making sure that you don't have priority inversion issues and things like that. So request priorities and deadlines through the system.
Priority propagation.
Right. So it's really more about making sure that there's nothing in the specification that would kind of prevent the right thing from happening in that regard.
So is the OMG working on some kind of modernized CORBA? For example, the language mappings, especially for C++ and Java, have been criticized a lot for the verbosity and stuff. Is there something happening, or is it pretty much, that's how it is? And
my opinion is they won't change them. I think the issue is, first of all, this issue comes up in the OMG every couple of years. Someone says, we've got to fix these mappings. And no one is objecting, but people say, well, are the vendors really going to pick up the new mappings and implement them? The OMG has a policy now that if they adopt a technology as a standard, they have to have, I think, at least one implementation of it before it'll be adopted. Like, it won't even be adopted at all if there's nobody implementing it.
Which is a good thing for a change.
It's nice to have for standards.
Yeah.
And so I think people are worried the vendors would not implement it. Now, the open source ORBs may implement because they have more flexibility, like with our Orbicus orb, for example, which is not open source but source available. We could maybe do something like that. But our customers really don't want to have to go retool their code because, again, it's already out there, it's deployed. They're not really actively developing it, but they're actively using it. So if it's going to happen, it would happen in the real-time area because, again, that's where the action is.
Music plays,
in terms of my involvement in the OMG, I haven't been to a meeting in a while now. The last thing I worked on was CORBA reflection, which became a standard. It was actually something that I did kind of single-handedly almost. Well, that's not entirely true. There was Frank Pilhofer of Mercury Systems helped me out quite a bit with the reflection, but it was something that I put into the OMG as an RFC. And the reason I put it in, or what it is, it's really introspection. So an object should have all of its metadata available at runtime, and it actually does have its metadata available at runtime, but it's never been exposed before. And because we were trying to take our customers forward into the world of web services, so we want to keep all their CORBA objects and systems running, but be able to get at them through web services applications. I needed a way to go to an object, CORBA object, and just say, give me your metadata, give me your IDL, basically. And you could do that through the interface repository, standard part of CORBA, but nobody really implements it. And it's another process that would have to be running somewhere, and most operators don't want to do that in production. So this way, the metadata is already in the object because it's used for dispatching and marshalling and stuff. So this is just an interface.
Serializing the data.
Yeah, that you could ask an object, say, are you reflective? You narrow to a reflection interface, and if that works, then you can ask it for its metadata, and you can get it in the form of an interface repository struct that has everything in it. So all the data about base interfaces, all the operations, all the parameters, everything like that. Or you could actually get it back as XML. And I know a lot of people go, ooh, the XML, that's bad. But when you're dealing with web services, you're already dealing with XML. So you can actually pull the XML, and it's a representation of the metadata that's in the object.
So you already mentioned web services. So the question, are they going to replace CORBA? I know this is a kind of simplified question, but what's your opinion there? Are they going to be as fast, as efficient,
I think there are some reasonably fast SOAP stacks. We have an open source project currently in the Apache incubator that a lot of IONA engineers are contributing to called Celtics Fire. And Celtics Fire is a combination of two projects. One was Celtics that we did in the Object Web open source community, and then Xfire, which was, I believe, at Codehouse. And Xfire is called the fastest SOAP stack on the planet. Right, so we combine the two, and it's, again, in the Apache incubator. And I just saw some figures on the performance. And so if you compare the performance of Celtics Fire to Celtics, there's quite a huge difference, improvement. And I don't know that it will ever be as fast as CORBA systems. There are, especially some of the embedded or real-time systems that are
the parsing is
really fast. But the point about web services, I don't think they're really meant as a replacement for CORBA. I think web services is more about kind of a higher level of integration than CORBA did. We have the Artix product, for example, at IONA, and what it does is it uses web services as an abstraction of kind of middleware. So middleware. Yeah, you might have a CORBA object that you need to get talking to some Tuxedo service. And maybe there's some MQ in your enterprise and Tibco and things like that. So this, what Artix can do is sort of abstract all that and make the development of service-oriented systems such that you're programming against the WSDL, and all the details of the transports and the protocols underneath are all hidden. Mm-hmm. So, you might have one call going over IOP, and then the next call to this other service going over MQ. And I think I suppose you could technically say that CORBA could do that because IOP was just one protocol that CORBA could have supported, but it's also the model of programming. There's the IDL versus the WSDL and coupling issues and again back into language mappings and stuff like that. So there are differences, and people seem to like Arctics. It's a little hard to explain because it's classified as an enterprise service bus, where most enterprise service buses are these centralized kind of hub-oriented systems, glorified JMS. Our system is extensible and distributed. There's really no central bus or hub, so it's a little hard to explain. But
maybe also due to the fact that nobody really knows what an enterprise service bus really is.
That's also an issue, I suppose.
So, do you consider web services more like RPC with angle brackets, or do you think it's more like messaging, or how would you classify?
I think over time it's changed. So when I first started, I've known Don Box for many years, and he kind of called me on the phone and said, "We're putting this SOAP thing together, and would you like to look at it?" So we took a look at it, and it was kind of interesting. And I think the thing about it was just another way of getting messages from one point to another, and sort of, you had these wars between CORBA and COM, and they didn't sort of get along and stuff like that. Yeah. So SOAP initially started out as RPC and very much oriented around the same kinds of things that CORBA and COM were already doing. But I think over time people realized that if you're dealing with XML, you're really dealing with documents. Right. And so it's evolved, I would say, to a document passing system. Yeah. Now, that's not to say that people aren't doing RPC with it. Yeah. That's actually one of my pet peeves, is this impedance mismatch of trying to map XML into objects or vice versa. Yeah. And it's just come from years of struggling with that mapping issue. I've written a number of columns about it and in my blog, and whenever every chance I get, basically. We'll put the blog on the show notes so people can read. There you go. So I think the more advanced web service developers are passing messages around, documents specifically, and they deal with documents. They don't try to convert it into Java or into C++ or whatever it is. They use it as a document, and in that case, it's not so much RPC anymore. It's really more like messaging. So that's also where I think one of the really measurable advantages of web services or document-oriented communication lies that if you, for example, take a CORBA IDL, structure interface, all the structures are compiled into the stubs. So if you evolve the definition of the struct, basically your ORB crashes or something like that. Right. If you have an interpreted data structure, you're much more flexible. You don't have to rebuild the infrastructure to evolve the document structure. Right. That gets into versioning, which is a really hard problem, especially as you know. Enterprise-wide stuff. Right. And so it sort of moves, like what you just described, the versioning problem is propagated all through your applications. Yep. Whereas I think with a document passing, it's more like, the versioning is in the document. It's still hard, but at least you've kind of gotten it out of your application. Right, and you don't have to recompile stuff. Right. I mean, I've worked for a customer where it took a week to change, to add an attribute to a data structure because they had to rebuild the whole infrastructure. Right. You have to rebuild, redeploy, retest, and the operators, system guys who actually run in production don't want to take a new version unless they absolutely have to. So what do you think about all those WS whatever standards? Are they going to be as, to put it cynical, as pervasive as all those CORBA things, where only like 10% of the facilities and services have actually been implemented, or 20%? So is this going to change now, or same thing? I think it's going to be the same. I think I'm a big fan of standards in the sense that we need standards. They're important to the industry. What I'm not a big fan of is me personally working on them.
That's funny. I talked to a couple of people at CHAO, and everybody said, these OMG meetings, it's so awful to go there.
So I've been in OMG, I've been in W3C, I don't think it's so much the organization as it is just the process is political and social by nature.
Yes.
You do get, most people are there to try to do reasonable work, but you do get people that are there seemingly to make other people's lives difficult. I don't know. Yeah. And so you wind up with kind of two issues. One, specs are just hard to work on to begin with. But I think you also have people that are sort of like professional standards people, and that's their entire job is making standards. So for them to start up a new spec and say, hey, we need a standard in this space, it doesn't really, seem to affect them in the sense like, do we really need this? Are you really thinking this through? In the web services space, there is still no architecture, right? There was a WS architecture group that I was on in the W3C years ago that really never produced anything. And without something like that to kind of guide...
a coherent picture.
Right. Like, where do you put the specs? How do they fit together? And things like that. So I think there are a lot of specs that are either going to be very, in very small niches or just won't be used at all. Generally, I think, the way the WS stuff has been put together is kind of like you get big companies that write the spec to begin with and then bring it to a standards body, and I'd rather it's better than the design by committee, starting from scratch in the committee. But at the same time, it's sort of like you're kind of forced to start with their assumptions and their designs, and so it has a good and bad side to it.
One comment I heard yesterday on that was that an OMG standard is a political document masking as a software specification. I like that.
It's very good.
So I'm not going to say who.
Don't tell Richard Soley that, though. He's much larger than I am.
He's probably going to laugh about it. So how important do you think are middleware standards and tools today? Obviously, you need them at runtime to ensure quality of service. But if you adopt like a model-driven approach, like the stuff Doug Schmidt is talking about, you could argue that it doesn't really matter what specific middleware you're using from an API programmer's point of view, because you have all those abstractions, and then you have a generator that generates, whatever WSTL, and then you have the web service, or it generates IDL. So, any opinion there?
Well, I'm not a big fan of the modeling stuff because it just seems like it's been going on and on for years, and I don't know that they're making really good progress. I know they're making some, so Doug may be unhappy with me for saying that, but I think there is something, and it sort of goes back to what we did with Artix, the whole kind of, there's multiple middleware systems and they need to be joined together, and systems like Artix can do that. But I think the standards are still very important because you get this fragmentation in the enterprise due to mergers and acquisitions, due to different organizations with their own purchasing decisions, and then you reorg and find this organization bought all MQ series or something, and this one's all CORBA. Now they have to interoperate, and how does that work? So I think, especially in the messaging side of things, there hasn't been any protocol standards at all, right? So if you buy MQ from one person and MQ from another, or JMS from anybody, you're getting a different protocol every time. So, that's another thing that I'm working on now is the advanced message queuing protocol, which was put together by the financial community, primarily J.P. Morgan, Chase and Company, and that's on its track, or on the road, I suppose, to be a standard.
A standard by the OMG or what?
No, there's no standards body associated with it yet. There's an AMQP working group, which has got a number of companies involved.
And how is that different from, let's say, JMS or MQ series? So what's the
the difference is it's actually
2-minute marketing plug.
On the wire protocol for messaging. So anybody implementing AMQ should interoperate with anybody else implementing AMQ.
Like IOP for message passing, just
exactly.
for RPC.
Right, for messaging. So there's a Cupid project in the Apache Incubator open source project that implements AMQ. There's also some commercial products from, I know of one from iMatix. And so there are implementations of these, and it's interesting because the standards, have been so important in the sort of RPC style of middleware for many years now. Yes. And now messaging is finally getting standards. So I think it's going to have a very large effect on the messaging area. The fact not only do you have a standard, but now you have this open source system that's, it's already there. You can go to Cupid at incubator.apache.org, look for the Cupid project, SVN checkout, and you actually have a working broker today written in Java, another one in C++, and clients in those languages and in Ruby and in Python. So
this brings us to the question what your working focus is today. So I take it's this AMQ thing.
Well, if my manager were here, I'd say I'm 100% on AMQ because that's what he tells me every day. In reality, I always have a variety of projects running, but most of my time is on AMQ. I have I suppose it's like a hobby, but this dynamic language stuff that I've been working on for quite a while. I just think their languages like Ruby and Python are just very expressive. You can say so much in so few lines of code. So I've been working on, I did a JavaScript server-side implementation for Celtics and Celtics Fire. So you can write your server implementation in JavaScript or in E4X, which is a XML handling language based over the top of JavaScript. And then I was working on some Ruby clients for Artix, and the expressiveness is amazing. Like you do in 4 or 5 lines of Ruby what 70 or 80 lines of C++ can do. So that's kind of another project. And then I always have my columns to write and,
usual PR stuff.
Yeah. Well, I've been writing, it's called toward integration. I've been writing that for, it'll be 5 years, I think, in January. And it's interesting because it's like when Doug Schmidt and I had a column for many years, it was all about CORBA. This column's a little more general, so it's about integration, middleware. I can cover a variety of things. So that's that comes up every couple months. I have to write one of those. I used to do a lot more traveling and speaking at conferences, but been trying to tone that down a bit. So JAU this year is the only one.
We're actually recording this at the JAU conference, and it's really one of the better conferences.
My favorite.
Many people will say that. I would agree.
Right.
Yeah. So before we wrap this up, let's maybe visit SOA a little bit. So, what's the role of SOA you see in the enterprise, and how? I mean, there was this panel on what's left to say on SOA, and I get the impression there is not very much to say about SOA because it's kind of components done right or whatever. So, any take on that?
Well, I think SOA is very important, first of all. But it's not as hyped, I'd say, as some people would like to make it. It really comes down to fairly fundamental, I say, software engineering principles. Componentization, modularity, loose coupling. Nice cohesive services put together and joined together,
self-sustaining kind of.
So I think. The panel, obviously I was on the panel because that's the track I spoke in. But I think the panel, what was interesting to me about both the track and the panel is that we have a really good understanding of the technology and the technical hurdles to getting a SOA in place. What we don't have a real good understanding of is the non-technical side.
Which would be?
Well, some of the issues around which group in the enterprise builds the services? Is there a group that gets paid to build services for other groups? Does every group build their own services? What if those groups have to interoperate some point in the future?
What's the scope of a data structure? Is it global, local to service?
Do you have one sort of enterprise-wide agreement on what a customer profile looks like versus every group having their own? You can even get into issues like certain managers may want control over certain things that they are resisting SOA because it sort of removes some of their control or takes away part of their empire or things like that. You might have CEOs or C-level executives that don't quite understand how SOA can affect their business. Actually, it could go both ways. You could have people who have sort of never heard of it and therefore don't even want to think about it.
Yep.
Or you might have the C-level person who kind of hears about it and says, we have to do this.
We are doing this, yeah.
And, you guys make it happen without any guidance and without, addressing these non-technical issues in the organization. So it's interesting in that track. I think all the speakers touched on that.
Yes.
And that's very important. The whole governance side of SOA, where you have repositories that kind of, here's your services, here's the policies for using them, and it's all tied into that. So
it's interesting because many people talk about SOA as being the alignment of business and IT, this business-driven stuff, and I never could relate to that very much because in ethe it doesn't say service-oriented business, it says service-oriented architecture, so it's an architectural thing. But the organizational issues you touched upon, they're different from the business issues, and I think they're certainly challenges.
Yeah, I think SOA is ultimately directed at making business value. So
but isn't that true for any IT endeavor?
Right. And SOA is one way to do it.
Yeah.
And the fact that architecture is in the name is probably wrong.
Maybe.
I think when I was at JAU 2 years ago, I gave a talk where I said that SOA stands for service-oriented architecture, but that's actually not what it is. And I had a list of 12 things that SOA isn't. That was one of them. And I think that's some of the backlash that SOA gets, is it's somewhat misnamed. It's really more around identifying the services in your business that are common across business processes, that can be reused across processes and shared among groups. And it's really ultimately an IT cost saver, right? If you do it right.
Yeah. Okay. So anything else you want to say? Want to let us know about your passion?
Well, I mentioned the dynamic language thing. That's really sort of big in my mind.
Yeah.
I just think there's so much to it, and it may be, an overreaction from having years of C++ and Java. That's all every day. But I think that's an area I'm going to be working a lot more on going forward.
So we're waiting for a CORBA mapping for Ruby, right?
Well, there already is one for Python.
Okay.
So,
Okay. Thank you very much for being on the show, and
Thank you.
Have a good time playing with Ruby.
Thanks.
Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.